technique help in identifying potential degradation mechanisms or structural instabilities in battery materials? What future advancements in XRD technology could further improve our ability to analyze materials at an atomic level? How does the material's structural stability contribute to its overall performance in battery applications? What factors determine the reversibility of the material during the charge and discharge cycles? How does the rate of change in cell volume, which is only 1.89%, affect the efficiency and durability of the material? What makes electrochemical in situ synchrotron XAFS a valuable tool for studying charge compensation mechanisms? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does XAFS help in identifying the electronic structure and local structural evolution of sodium-ion battery electrode materials? Why is it important to track these changes during the charge and discharge process? What specific insights can be gained from using synchrotron radiation for electrochemical analysis? How does ZANS mapping enhance the detection of subtle structural and valence changes in Ni3s2 electrode materials? Why are composite components and multiple valence states particularly significant in battery materials? How does ZANS mapping contribute to understanding the efficiency of sodium storage in the electrode material? What makes this technique reliable in determining whether the material reacts adequately during battery operation? How can ZANS mapping be used to assess whether short-range structural changes occur within the material? Why is it crucial to monitor the reversibility of the reaction process in electrode materials? How do valence changes impact the electrochemical behavior of the material? What experimental techniques are commonly used alongside ZANS mapping to validate findings? How does the interpretation of XAFS and ZANS data help optimize battery materials for better performance? What challenges exist in capturing and analyzing subtle structural changes during battery operation? How do researchers ensure that the data obtained from synchrotron techniques is accurate and meaningful? What future advancements in XAFS and ZANS mapping could further improve our ability to study sodium-ion battery materials? How does synchrotron technology compare to other spectroscopic methods used in battery research? What role does synchrotron-based characterization play in developing next-generation energy storage systems? How does in situ synchrotron radiation characterization enhance the study of battery materials and their electrochemical processes? What advantages does electrochemical in situ synchrotron radiation spectroscopy offer in analyzing battery performance and charge compensation mechanisms? How does synchrotron radiation allow for real-time observation of structural changes during charge and discharge cycles? What